Lesson 3.8, the standard form of a linear equation. We talked in previous lesson that there were three basic forms of an equation. We've worked with the slope-intercept form and the point-slope form, and now we're going to talk about standard form. So quickly let's review the forms. We have the standard form, which is of the form ax plus by equals c. Now with the standard form, a, b, and c are all integers. There are no decimals and no fractions in standard form. A must be positive. In the slope-intercept form, we have y equals mx plus b, where m is the slope and b is the y-intercept. And in the point-slope form, we have y minus y1 is equal to m times x minus x1. X and y stay variables, and x1 and y1 are a point on the line, and it can be any point on the line. M is the slope. So the first thing we need to do is identify the different forms of an equation, so we can say whether they're in standard, slope-intercept, point-slope, or none. Okay, so looking at the first example, we have 3x minus 4y equals 11. We have x and then y. We have all integers, and the first integer is positive, so this is standard form. On our second example, we have y is equal to 4x minus 5. This is in the slope-intercept form, because we have y equals mx plus b. Here I have 1/2 x minus 3y equals 8. We have the x and then the y, but we have a fraction, so this is in no specific form. Here I have 2x plus 5y minus 6 equals 12. I have integers. I have x and y, but I have this minus 6 on the same side of the equals, and in standard form we can't have this, so this is no particular form either. Here I have y plus 8 is equal to 3 times x minus 4. This is in point-slope form. Even though this is a plus, it's the same thing as saying y minus negative 8. So this is point-slope. Here I have negative 2x minus 11y equals 8. I have all integers. Everything's in the right position. However, because this 2 is negative, it is not standard form. Standard form requires this to be negative or positive. Y equals 4x. This could have a plus 0 on it, so that's y equals mx plus b. So this is slope-intercept. Here I have y minus 2 equals 4x. This is in no specific form. And finally I have 6x minus 4y equals negative 13. These are all integers. I have an x, a y, and my coefficient of my x is positive, so this is standard form. Okay, next we need to be able to graph equations in standard form using intercepts. Another method for graphing the equation of a line is to graph using intercepts. Now, to graph using intercepts, this works best when the x and y coefficients divide evenly into the constant that is present. That's when we use this. Okay, so looking at our example problem, I have 3 and 4 both divide evenly into 24, so this would be a good time to use intercepts. Now, intercepts are where the graph hits the x and y axis. The x-intercept is where it hits the x-axis, and the y-intercept is where it hits the y-axis. At the x-intercept, that occurs when y equals 0. And the y-intercept occurs when x equals 0. So to find the intercepts, we can remove the other variable. So to find the x-intercept, I can plug in 3x is equal to negative 24 and solve for x. So I divide both sides by 3 to get x is equal to negative 8. This is the x-intercept. To get the y-intercept, I set 4y equal to negative 24, divide both sides by 4, and I get that y is equal to negative 6. Now, in order to graph this in the amount of space I have, I need to make sure I can go negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. I can make this my y-axis. So there's my y-axis. And I need to be able to go down at least 6, so I'll make my x-axis a little on the higher side. Here's my x-axis. Now you don't have to have exactly even to where your y-axis and your x-axis cut each other off in the middle. You can shift it around to give yourself the space that you need. So x is negative 8, so I go to negative 8. 1, 2, 3, 4, 5, 6, 7, 8, and I put a dot right on the x-axis. Y is negative 6, so I put a dot right on the y-axis. And I connect my intercepts. And this is the equation of the line 3x plus 4y equals negative 24. Okay, we'll do one more example using intercepts. Messy. Okay, let's try 5x minus 3y is equal to 15. I'll set my 5x equal to 15 and solve for x, and then I get x equals 3. I set my negative 3y equal to 15 and I solve for y, and I get y is equal to negative 5. I'll make my axes. I put a dot on 3 for the x and negative 5 for the y, and connect my intercepts with the line of the equation. Five x minus 3y is equal to 15. Okay, next we need to be able to convert from slope-intercept to standard form. And what we want to do is we need to rearrange the terms in the equation, and then we need to make sure everything is an integer and that the x term is positive. So first, when we talk about rearranging, I can do this in two ways. I can subtract 3x from both sides, or I can pick the 3x and then move it over. If I change sides, I have to change signs. It's like when a really well-noted sports professional changes teams, but he gets to keep his number. He may keep his number, but they put it on a different jersey. So the sign is like the jersey. So when I move this 3x over, it becomes negative. The y was positive, so that's plus y is equal to negative 6. Everything's an integer, so I don't have to worry about that, but this 3 is negative, and it needs to be positive to be in standard form. So essentially what I'll do is I'll multiply the whole equation by negative 1, which will change all of the signs. And now I'm in standard form. Here I have a negative 3/5 x, so I'm going to move that over, and it becomes positive 3/5 x plus y is equal to 3. Now I don't want a fraction, I need integers, so I'm going to multiply every single term by 5. So I multiply 5 times 3/5, 5 times y, and 5 times 3. When I multiply 5 times 3/5, these 5's cancel. That's why I chose 5, and I get 3x plus 5y is equal to 15, and I am now in standard form. Here I have a 2/3 x. I'm going to move that over, and it becomes negative. Now I want to get rid of this 3 in the denominator and the negative at the same time, so I'm going to multiply the entire equation by negative 3. The 3 and the negative 3 cancel, the negative and the negative cancel, so I'm left with 2x. I have negative 3y and 18. And lastly, I'll move this 7/2 over. It becomes negative. And to clear the 2 and the negative, I'll multiply both sides, or all side terms, by negative 2. Negative 2 times negative 7/2, the 2's cancel and the negatives cancel, giving me a 7x minus 2y is equal to negative 22. Okay, to convert from standard form to slope-intercept form is we work backwards. So we solve the equation for y. We want to make it into the format of y equals mx plus b. So basically we do the opposite of what we just did. Instead of moving the x from the left to the right, from the right to the left, we're going to move it from the left to the right. So we'll move it over here. So I get 4y is equal to negative 3x minus 8. So my first step is move x. My second step is to divide by the coefficient on y. Okay, so I divide everything, and that's everything. So I get y is equal to negative 3/4 x minus 2. Okay, next I'll move my 6x over. I have negative 7y is equal to negative 6x plus 9. I divide everything by negative 7. So I get y is equal to negative over negative gives me a positive 6/7 x minus, because of this negative 7, 9/7. Okay, I move my 5x over. I have negative 3y is equal to negative 5x. Again, it was positive, so now it's negative because I switched signs. I divide everything by negative 3. And I get y is equal to negative over negative is a positive. And 9 divided by negative 3 is negative 3. Last example, I'm going to move my 2 over. I have negative 8y is equal to negative 2x plus 32. I divide everything by negative 8. And I get y is equal to 2 over 8. They both divide by 2, so I get 1 over 4x minus 4.